This situation is emotionally charged, and it's on the verge of a dramatic event. There's no certainty about the exact timing of what's coming. It could happen tomorrow or perhaps even during this transmission. The event will be striking, like a glowing second sun. Recently, the James Webb Space Telescope discovered a surprising 250% increase in the brightness of Betelgeuse, the red giant star located at the shoulder of the Orion constellation. This unexpected behavior has sparked significant interest and curiosity. Some speculate that this sudden increase in luminosity may signal that Betelgeuse is gearing up to explode in a supernova, but the exact timing of this remains uncertain. Experts believe the event could occur sooner than expected. Join us as we delve into the depths of space and uncover the mysteries surrounding this colossal star, a discovery that could drastically alter our understanding of the cosmos. Despite the unfamiliarity of its name, you've likely admired the brilliance of Betelgeuse, a vivid bronze-colored glow shining brightly at Orion's shoulder, part of a well-known star cluster. Its enormity is staggering. If placed at the center of our solar system, its outer layer would stretch far beyond Jupiter's orbit. This colossal star continues to captivate observers, and unlike most stars, Betelgeuse exhibits noticeable fluctuations in its behavior over time. Due to its proximity to our system, classified as a semi-irregular variable star, its brightness fluctuates predictably, hinting at an eventual breakdown that might lead to a cosmic explosion. Recently, Betelgeuse has become even brighter due to remarkable shifts in its luminosity. Among these fluctuations was a dramatic increase on May 20, 2023, when scientists astonishingly recorded a 142% rise in brightness, followed by a later update confirming a 150% increase. Astrophysicists from the Harvard-Smithsonian Center for Astrophysics pointed out that Betelgeuse has now become the 7th brightest star in the night sky, climbing 3 positions from its usual 10th place. From the southern hemisphere, the star shines visibly in the night sky, a stunning sight at the shoulder of the Orion constellation. Dr. Sarah Webb, an astrophysicist at Swinburne University of Technology in Australia, emphasizes the importance of studying Betelgeuse as it offers a unique opportunity to examine the final stage of a massive star's life cycle, shedding valuable light on the behavior of red giants before they explode as supernovae. When Betelgeuse does eventually explode, it could become exceptionally bright for around a week, possibly casting shadows at night. This possibility has both amateur astronomers and professional space scientists eagerly anticipating the event. Heidi Morris, a scientist at Los Alamos National Laboratory and the president of the Padaro Stargazers and Cosmology Club, observes that the consistent interest in Betelgeuse's brightness variations is a phenomenon that has intrigued multiple cultures for many years. Currently, Betelgeuse's brightness cycle spans about 130 days, much shorter than its typical multi-year cycle, which makes these rapid changes a rare opportunity for astronomers to study the stellar anomaly in greater detail, offering unprecedented insight into the last phases of a star's existence. The erratic behavior of Betelgeuse began in 2019 when the star suddenly ejected a portion of its outer atmosphere. These variations in brightness are unusual for Betelgeuse, which has led to questions about whether it is nearing its end and may explode into a supernova. According to a study authored by Dupree and other researchers from Harvard and the University of California, Berkeley, it may take another 5 to 10 years for Betelgeuse to return to its expected 400-day brightness cycle. Since the star has displayed unusual behavior in terms of both its light and its rotation speed, astronomers are left wondering whether these fluctuations are the beginning of the end for this massive red supergiant. Betelgeuse is indeed a massive star nearing the end of its life, exhausting its fuel and entering a phase of rapid evolution. As its core collapses under its own immense mass, it could trigger a supernova explosion that would have the power to overshadow entire planets. However, the precise timing of this event remains uncertain. Dr. Pierre, a professor of cosmology at the University of Portsmouth, notes that predicting the timing of supernovae remains challenging due to the lack of comprehensive historical data and the complexity of stellar evolution. Betelgeuse is currently undergoing fusion processes, constantly evolving by fusing elements like helium, carbon, oxygen, silicon, and eventually iron. As a red giant star, it converts helium into carbon at its core, a process that takes millions of years. Eventually, It will begin to melt heavier elements until it reaches a point where it can no longer support fusion reactions, leading to a gravitational collapse and possibly forming a black hole or a neutron star. While some theorists predict that Betelgeuse's explosion is imminent, historical data suggests that the star has been gradually growing red over the years, which implies that it could take a significant amount of time before it reaches the supernova stage. NASA's estimates indicate that Betelgeuse isn't expected to explode for another 100,000 years, offering reassurance that it is unlikely to happen within our lifetimes. Despite the uncertainty surrounding its exact future, the unpredictable nature of Betelgeuse's behavior continues to captivate scientists, and advancements in our understanding of stellar evolution are still ongoing. Dr. Sarah Webb reminds us to remain open to all possibilities, even as the chances of witnessing Betelgeuse's explosion in our lifetime seem remote. By keeping track of its changes, we may make further scientific breakthroughs that open the door to new discoveries in the universe. It is important to keep in mind that our observations of Betelgeuse are essentially witnessing the past. The light we see from the star is over 600 years old, meaning Betelgeuse may have already exploded by now and we wouldn't yet know it. Although this is a possibility, it is far from certain. History has shown us that our assumptions in astronomy can be challenged. For instance, prior to 1987, astronomers believed that only red supergiants could go supernova. But that year, a massive blue star in another galaxy exploded, surprising the entire academic community. This shows there is still much to learn, and surprises may be ahead. Observing Betelgeuse and other massive stars provides us with an opportunity to expand our understanding of celestial phenomena. Even if the explosion is not imminent, the star's unpredictable behavior is still fascinating and reveals important aspects of stellar physics. Currently, Betelgeuse's increased brightness in 2023 has reignited global excitement, sparking renewed interest in this astronomical giant. The star's erratic behavior continues to prompt intriguing questions about when and how its inevitable explosion will occur. Some astronomers believe that the current surge in brightness is a sign that Betelgeuse is nearing the end of its life, while others caution that the star might simply be going through an unusual but typical phase of evolution. Regardless of the cause, these fluctuations offer a thrilling chance to observe stellar behavior in real time, giving astronomers and stargazers an opportunity to test hypotheses about the life cycle of massive stars and their eventual demise. Despite the uncertainty surrounding Betelgeuse's current activity, its history provides valuable clues. As previously noted, Betelgeuse has undergone significant fluctuations in brightness over the centuries, and its periodic variations are thought to be part of the normal life cycle of red supergiants. However, the scale of the recent brightness surge has triggered renewed excitement in the scientific community, prompting further investigation into whether these changes are an early indication of an impending supernova or just another instance of the star's typical behavior. As research continues, one thing is clear: Betelgeuse remains an exceptional subject of scientific study. While its eventual explosion remains a distant possibility, ongoing monitoring of the star promises to provide crucial insights into stellar evolution. By observing stars like Betelgeuse, astronomers can refine models of stellar life cycles, offering glimpses into the processes that shape our universe. Meanwhile, skywatchers will continue to marvel at Betelgeuse's fluctuating brilliance. Whether it is dimming or brightening, the star's unpredictable nature ensures that it remains a captivating subject for both amateur and professional astronomers. As we continue to monitor its evolution, the possibility of a spectacular supernova event adds an element of cosmic drama to an already fascinating celestial spectacle. Ultimately, Betelgeuse's inevitable fate will deepen our understanding of the cosmos. While we may not live to witness the star's final explosion, the knowledge gained from studying Betelgeuse and other massive stars will shape our understanding of the universe for generations. For now, both astronomers and stargazers remain anxiously tuned to the skies, eagerly awaiting the next chapter in the life of this mysterious red supergiant. As we remain fixated on Betelgeuse, its unpredictable behavior continues to stir curiosity and inspire a wave of scientific exploration. The most recent fluctuations in brightness provide an exciting opportunity to probe deeper into the nature of massive stars and their impending transformations. With each new surge or dimming, astronomers are able to test and refine their theories about stellar life cycles, especially concerning the behavior of red supergiants in their final years. These stars are notorious for their unpredictability, and Betelgeuse has become a prime example of how even the most established knowledge about stellar evolution can be challenged by new unforeseen behavior. Scientists across the globe are closely monitoring Betelgeuse for signs that could confirm or deny the theories surrounding its potential to explode as a supernova. Each new observation contributes valuable data to the ongoing debate. As more advanced telescopes and observation methods come online, they allow for increasingly accurate measurements of Betelgeuse's fluctuating brightness and its evolving behavior. These technological advancements provide an unprecedented opportunity to closely observe a star as it nears the end of its life cycle, offering insights that were once reserved for the distant future. The excitement surrounding Betelgeuse has prompted even those without a background in astronomy to take note. Stargazers and casual observers of the night sky are captivated by the star's shifting luminosity. The sight of Betelgeuse glowing with such intensity in the night sky is a visual reminder of the immense forces at work in the universe. Forces that will soon culminate in the star's transformation into a supernova. The possibility that we may witness such a grand cosmic spectacle in our lifetimes adds a sense of wonder to our ongoing observation of the star. While there are still uncertainties about the exact timing of this event, the sheer possibility that it could occur in the near future is enough to keep both amateurs and professionals eagerly scanning the heavens. Betelgeuse's behavior has become a significant focus of both observational astronomy and public interest. The star's sudden dimming in 2019 was one of the most talked about events in recent astronomical history. For months, astronomers and stargazers alike watched in awe as the star seemed to fade, triggering an array of theories about what might have caused such a dramatic change. Was Betelgeuse on the brink of a supernova? Was it simply undergoing a typical phase of stellar evolution? Researchers worked tirelessly to answer these questions, eventually determining that the dimming was likely caused by a cloud of dust and gas that obscured the star's light, rather than a sign of an impending explosion. Nonetheless, this event sparked widespread fascination and renewed interest in Betelgeuse, positioning it as one of the most important stars in the study of star life cycles. Since then, Betelgeuse has been the subject of extensive study, with astronomers using every available tool to learn more about its fluctuating brightness and the causes behind its erratic behavior. The star's current burst of brightness in 2023 is yet another piece of the puzzle, prompting fresh questions about whether it marks the beginning of its final stages. While the star has undergone fluctuations in brightness throughout its life, the magnitude of these recent changes has raised the stakes, with some scientists speculating that Betelgeuse could be nearing the point where it will transition from a red supergiant into a supernova. In the meantime, other red supergiants in our galaxy are also under scrutiny. While Betelgeuse remains one of the most prominent examples of a massive star nearing its end, it is far from the only one. There are other stars, like Epsilon Cooney, that are similarly undergoing changes, and some may even explode before Betelgeuse does. However, as Betelgeuse is one of the most studied stars in the night sky, it provides an unparalleled opportunity for researchers to learn more about the processes that govern the lives of these enormous stellar bodies. By comparing Betelgeuse's behavior to that of other red supergiants, scientists can refine their models of stellar evolution and gain a better understanding of what might happen when these stars reach the end of their lives. The potential for Betelgeuse to become a supernova has captivated the imagination of not only astronomers but also the general public. If it does eventually explode, it will be an event of unparalleled magnitude. The light from the explosion will likely be visible to the naked eye for weeks, and its brightness could surpass that of many of the stars currently visible in the night sky. Such an event would be a once-in-a-lifetime experience for anyone fortunate enough to witness it, offering a dramatic and awe-inspiring spectacle that would forever be etched in the memories of those who observe it. For now, we can only speculate about the exact timing and nature of Betelgeuse's explosion. Predictions about the timing of supernovae are notoriously difficult to make, as they depend on a variety of factors that are not fully understood. For example, while some stars may transition from their red giant phase into a supernova relatively quickly, others may undergo a much slower transformation. Betelgeuse's behavior over the next few years will be critical in helping astronomers refine their understanding of these processes and improve their ability to predict the future evolution of other massive stars. As we continue to observe Betelgeuse's fluctuating brightness, it will provide valuable data that could one day help scientists predict the behavior of other stars in similar stages of their life cycles. While the possibility of witnessing Betelgeuse's supernova remains uncertain, the excitement surrounding the star's behavior has led to renewed interest in the field of astronomy. The mystery of Betelgeuse's fluctuations has sparked the imaginations of people worldwide, prompting many to learn more about the fascinating science of stellar evolution. In addition, the star's unusual behavior has helped to shed light on some of the most intriguing aspects of the universe, including the processes that govern the life cycles of massive stars and the forces that shape the cosmos. Betelgeuse's evolution is far from the only astronomical mystery that continues to captivate researchers and stargazers alike. As new technologies emerge, scientists are gaining an ever deeper understanding of the universe, uncovering new phenomena and refining their models of cosmic processes. Whether or not we witness Betelgeuse's supernova during our lifetimes, the ongoing study of this enigmatic star will continue to push the boundaries of human knowledge and inspire future generations of astronomers. The eventual explosion of Betelgeuse, whenever it may occur, will likely remain a topic of interest and study for decades to come. Even if the star does not explode for thousands or even hundreds of thousands of years, the ongoing exploration of its behavior will provide critical insights into the final stages of a massive star's life. This knowledge will be invaluable in our quest to understand the life cycle of stars, the formation of black holes and neutron stars, and the fate of our universe as a whole. As we continue to watch Betelgeuse, it serves as a reminder of the ever-changing and mysterious nature of the cosmos. Whether it is dimming or brightening, its dramatic shifts offer a rare opportunity to observe the intricacies of stellar evolution firsthand. The ongoing study of the star promises to yield many discoveries, not only about Betelgeuse itself but also about the broader processes that govern the lives of stars. The excitement surrounding Betelgeuse's fluctuations has helped reignite interest in the study of red supergiants and their eventual transformation into supernovae. Ultimately, whether or not we live to see Betelgeuse's final explosion, the insights gained from studying this remarkable star will help expand our understanding of the universe for generations to come.